What if the universe isn't empty? Not empty in the way we usually mean it. Not empty of galaxies or energy or matter. Empty in a different sense. Empty of experience. Empty of anything it is like to be. The assumption underneath all of modern physics is that the universe is a physical system, nothing more. Particles, forces, fields, geometry. That is the complete list. And that assumption has never been tested. It has never even been formally stated as a hypothesis to be tested. It is just the water the field swims in. Here is the thing. There are researchers, serious researchers, with institutional affiliations, publishing in peer-reviewed journals, who have formally asked whether that assumption is correct, not as philosophy, as a technical problem. They have proposed frameworks, defined terms, identified measurable predictions, and published. And what happened after they published is where things get genuinely alarming. Almost nothing happened. The papers are there, the arguments are rigorous, the journals are real. David Chalmers named the central problem of consciousness in 1995, and it has been cited thousands of times. Giulio Tononi built a mathematical framework for measuring consciousness across physical systems, published it, and watched the field spend 20 years struggling to either confirm it or kill it. Roger Penrose, one of the most credentialed physicists alive, argued that consciousness is rooted in quantum processes in the brain, connecting human awareness directly to the structure of reality at its smallest scale. These are not fringe proposals. They are peer-reviewed, formally published, and sitting in the literature right now, and the institutions best positioned to pursue them have not pursued them. How has this not become the dominant narrative in every discussion of consciousness research? Why does the central question, not how the brain processes information, but why processing information produces experience at all, still have no funded research program dedicated to answering it after 30 years? And why do the researchers who take it seriously describe the same pattern of professional friction, the same quiet discouragement, the same institutional pressure to ask smaller questions? That is worth sitting with. Before you can understand what is strange about the silence, you need to understand what the question actually is. Not the popular version of it, not the mystical version, the technical version. Because the technical version is far more uncomfortable than anything a spiritual framework would ask. The question is this: consciousness exists. You are having an experience right now. That experience has qualities: color, sound, sensation, thought. Physics can describe everything happening in your brain at the level of neurons and signals and chemical gradients. It cannot explain, even in principle, why any of that produces something it feels like to be you. That gap is not a gap in the data, it is a gap in the framework. And some of the most careful thinkers in philosophy and physics have concluded that closing that gap may require changing the most basic assumption about what the universe is made of. The assumption that experience is something matter accidentally produces rather than something matter fundamentally is. Now look at what follows from that. If experience is fundamental, the universe has not been empty in the way physics assumed. It has had some form of interior since the first particles existed. Not thoughts, not feelings in any human sense. Something far more minimal than that, but something. And the formal frameworks built to describe that possibility are sitting in the published literature, largely ignored, while the field moves on to smaller questions. That is what this is about, not mysticism, not metaphor, the actual science, and what it means that the science keeps pointing somewhere the field is not built to look. Here is the thing about consciousness that nobody tells you up front. The scientific community has two completely different problems and has been quietly conflating them for decades. The first set of problems are what philosopher David Chalmers called the easy problems. Not easy in the sense that they are simple, easy in the sense that we at least know what solving them would look like. How does the brain process visual information? How does it store memories? How does it direct attention? How does it coordinate behavior? These are hard scientific questions. They require decades of careful work and sophisticated technology, but they are tractable. You can point to a mechanism, run an experiment, build a model, check whether the model makes accurate predictions. The methodology is clear, progress is measurable, and we have made enormous progress. Brain scanning technology today can track activity across hundreds of thousands of neurons in real time. We can identify which regions activate during fear, during language, during decision-making. We have detailed functional maps of what the brain does and when it does it. That part is working. That is the easy problem, and science is genuinely good at it. The hard problem is something else entirely. Here is the thing that should stop you. None of that work, none of the scanning, none of the mapping, none of the functional modeling touches the actual question. The actual question is not what the brain does. The actual question is why doing anything produces experience at all. Why does seeing red feel like something? Why does pain hurt rather than just triggering avoidance behavior with no interior sensation attached to it? Why is there a subjective, first-person quality to experience? Why is anyone home? You can describe every photon that hits the retina. You can trace the signal through the optic nerve. You can identify every neuron that fires in the visual cortex. And at the end of all of that, the question of why any of it is experienced, why there is something it is like to see red, remains completely open. Chalmers named this in 1995. The field acknowledged it. 30 years later, no one has closed it. This is not a failure of effort. This is a structural problem. Think of it this way. Imagine you are trying to explain why water is wet. You can describe H2O perfectly. 2 hydrogen atoms, 1 oxygen. Covalent bonds, molecular geometry, surface tension, the behavior of the molecule in bulk, all of it precisely modeled, and none of that description answers why it feels wet when you touch it. The sensation is not in the description. The subjective quality is not captured by the objective account. That gap between the third-person description and the first-person experience is exactly the hard problem, and it does not care how detailed your description gets. Neuroscience keeps producing better and better third-person descriptions, more resolution, more data points, better models of how signals travel and how regions interact. What it cannot produce, by its own methodology, is a first-person account of why all that activity generates experience. The tools are not built for that, and here is my position on that. This is not a temporary limitation we will outgrow with better equipment. The limitation is conceptual. The methodology of objective science describes structures and processes. It does not have a way to get inside them. What would actually solving this look like? You would need to explain why a specific physical arrangement of matter is not just processing information but experiencing something. You would need to explain why the neurons in your visual cortex do not simply fire in response to red wavelengths and trigger behavioral outputs. Why there is also an interior. Why there is the redness of red. Philosophers call these qualities qualia, and no physical description has ever explained them, not because we have not looked hard enough, but because the gap between description and experience is not the kind of gap that more description closes. Some researchers argue the hard problem will dissolve once we understand the brain well enough. That explanation has been offered for 30 years, and the problem has not dissolved. It has gotten sharper. The more precisely we model what the brain does, the more obvious it becomes that the model contains no experience. It is all mechanism, all process, with no account of why anything is felt. Other researchers argue the problem is an illusion, that there is no real explanatory gap, just a confusion about language. Chalmers spent significant effort explaining why that move does not work. The problem re-emerges every time you try to dissolve it, because the subjective quality of experience is not a linguistic confusion. It is the one thing you are certain of. You know there is something it is like to be you right now. That certainty is the problem. Explaining it is what nobody has managed to do. Here is what this means for everything that follows. Consciousness is not a solved problem with details left to fill in. It is a formally unsolved problem with a published definition of why it is hard and no consensus solution 30 years after that definition was written. The institutions keep producing data on the easy problems and calling it progress on the hard one. That is not dishonesty. That is how fields work when a question sits outside their methodology. More data does not close a conceptual gap, and the gap here is not about what the brain does. It is about why doing anything produces experience at all. The idea is older than the hard problem, older than neuroscience, older than the word consciousness itself. Before anyone had formalized what the hard problem even was, before brain scans existed, before the word neuroscience had been coined, thinkers across completely separate traditions kept arriving at the same uncomfortable position. Consciousness is not something matter produces, it is something matter has. That position has a name now, panpsychism. And the first thing you need to understand about it is that it is not a fringe idea that someone smuggled in from outside serious intellectual tradition. It is one of the oldest formal positions in philosophy, and the list of people who have held some version of it is not a list of mystics or cranks. Plato held a version of it. The Stoics held a version of it. Spinoza, who built one of the most rigorous philosophical systems in European history, held a version of it. Leibniz held a version of it. William James, who essentially founded American psychology, held a version of it. Alfred North Whitehead, a mathematician who co-authored the foundational text of modern logic with Bertrand Russell, spent the second half of his career developing a full metaphysical framework in which experience is a basic feature of the universe at every level. These are not people who lacked rigor. They are among the most technically demanding thinkers their eras produced, and they kept arriving at the same place. Here is the thing that should stop you for a moment. This is not a case of an idea surviving because it was never seriously challenged. Panpsychism has been challenged, discarded, and replaced repeatedly over the last 400 years. Materialism, the view that matter is fundamental and consciousness is something matter produces at sufficient complexity, became the dominant scientific framework, and it worked extraordinarily well for almost everything except the one problem it set out to solve, the hard problem, the question of why there is subjective experience at all. Every time that question gets asked with enough precision, materialism runs out of answers, and the tradition circles back to the same alternative. So what is the actual claim? Not the caricature version, the real one. Because the caricature is what most people hear first, and it is why most people dismiss the idea before they have understood it. The caricature says panpsychism means electrons have opinions, rocks are thinking, particles experience joy or suffering. That is not the claim, not even close. The actual claim is far more minimal, and that minimalism is exactly what makes it philosophically serious rather than poetic. The claim is this: whatever consciousness is at its most basic level, it is not something that appears out of nowhere when matter reaches a certain level of complexity. It is a fundamental feature of reality, present in some form at every level of physical organization, the way mass is, the way charge is. A particle does not have preferences. It does not have a perspective on its situation. What it may have is something so primitive, so utterly alien to anything in human vocabulary, that calling it experience at all is already an overstatement. A bare capacity to be affected. A micro-level property that, when organized into sufficiently complex structures, produces the kind of rich unified experience that you and I are having right now. The philosophers who take this seriously are not clay. Ming that quarks have an interior life. They are claiming that the interior life you have did not appear from nothing, and the only way to avoid that conclusion is to accept that it somehow assembled itself out of matter that had no experiential properties whatsoever, which is the move that keeps producing the hard problem. Here is what that means in practice. If you want to explain why there is something it is like to be you, you have two broad options. You can say consciousness emerged from non-conscious matter at some threshold of complexity, in which case you need to explain how that emergence works and nobody has done that. Or you can say the properties that eventually produce consciousness were present in simpler form all along, in which case you trade the emergence problem for a different set of questions. Panpsychism is the second option. It does not solve every problem, it creates new ones. But what it does not do is leave you staring at the same conceptual wall that materialism leaves you staring at. The history here is worth paying attention to. Every generation since the scientific revolution has assumed that the materialism problem is about to be solved with the next round of data, better brain imaging, more detailed neural mapping, finer-grained models of information processing. The assumption has always been that the gap is empirical, that we just need more information. What panpsychism says, and what a growing number of serious philosophers now say, is that the gap is not empirical, it is structural. More data about the brain tells you more about what the brain does. It does not tell you why doing anything produces experience. That is the move the tradition has been making wrong. And every decade that passes without a materialist solution to the hard problem is a decade in which the alternative position becomes harder to dismiss. David Chalmers, who named the hard problem, is a panpsychist. Philip Goff, one of the most widely read philosophers of mind working today, is a panpsychist. Christof Koch, who spent decades at the forefront of neuroscience research, has endorsed a version of it. These are not people who gave up on the science. They followed the science to where it pointed and found that it pointed somewhere the field is not comfortable going. The reason it keeps coming back is not that philosophers are stubborn. It is that the alternatives keep running into walls, and panpsychism is the one framework that does not. Before you can take panpsychism seriously, you have to reckon with the thing that makes most philosophers put it down. It is called the combination problem, and it is not a footnote objection. It is not the kind of thing you wave off with a paragraph and move on. It sits at the center of panpsychism's entire project, and the honest answer is that nobody has solved it. Not completely. Not in a way the field has accepted. Here is what the problem actually is. If consciousness is a fundamental feature of reality, present in some form at the level of particles, then trillions of those tiny conscious units make up your brain right now. Every electron, every quark, every subatomic piece of the structure inside your skull carries some minimal flicker of experience. That is the claim. And here is where it breaks. You do not experience trillions of separate flickering micro-awarenesses. You experience one thing, a single unified field of consciousness, one perspective, one continuous stream, one self that persists through time and connects every thought to every other thought. Where does that unity come from? Why does adding micro-experiences together produce a single unified me instead of a committee? A crowd of a trillion tiny awarenesses does not automatically become one awareness just because they are close to each other. If you put 10 people in a room, you do not get one shared consciousness. You get 10 separate ones. Why would particles be any different? Here is the thing that makes this harder than it looks. The problem is not just philosophical. There is actual neuroscience that cuts directly at our intuitions about unified consciousness, and it does not point in a reassuring direction. Split brain research. Starting in the 1960s, surgeons began treating severe epilepsy by severing the corpus callosum, the thick band of neural fibers connecting the brain's two hemispheres. The seizures improved, but something else happened. Researchers, including Roger Sperry, whose work earned a Nobel Prize in 1981, began running experiments on these patients, and what they found was deeply strange. When information was presented to only the left visual field, the right hemisphere processed it. When information was presented to only the right visual field, the left hemisphere processed it. And each hemisphere appeared to have its own responses, its own preferences, its own processing, independent of the other. What split-brain patients seemed to demonstrate was that the unified self you experience right now, I depend entirely on a specific piece of connective tissue in the middle of your brain. Sever that, and the unity fragments. Two separate streams of processing, two separate responses. The question of whether that constitutes one consciousness or two has never been settled. Philosophers and neuroscientists still argue about it, but the implication is uncomfortable either way. If consciousness can split like that, if unity is something that can be physically interrupted, then what exactly are we pointing at when we say the micro-experiences combine into one? Now, some panpsychists have tried to answer the combination problem directly. The attempts are worth taking seriously, even where they fall short. One approach reaches toward quantum entanglement. The idea is that entangled particles share quantum states in ways that cannot be reduced to the separate properties of each particle. They are correlated at a level that classical physics has no mechanism to explain. If something like that operates at the level of consciousness inside the brain, then perhaps micro-experiences do not simply add together the way objects in a pile add together. They entangle. They become something that is genuinely more than its parts in a non-metaphorical sense. Philosopher Philip Goff has explored this direction seriously. The problem is that entanglement in physics describes correlations between quantum states. It does not obviously describe a mechanism for fusing subjective experiences into a single unify. D-field. The analogy is suggestive, it is not a solution. Another approach runs through integrated information theory, which gets its full treatment in the section that follows this one. The short version is that IIT proposes consciousness corresponds to integrated information in a system, and that integration is what produces unified experience rather than fragmented micro-awarenesses. The combination problem on this view is not about adding experiences together, but about the structure of information flow in a system. High integration produces unified consciousness. Low integration produces something closer to separate processing streams. The split brain cases actually fit this framework reasonably well. Sever the corpus callosum, and you reduce integration. Consciousness may fragment accordingly. But here is the honest position on all of this. These frameworks are promising. Some of them are serious. None of them have closed the combination problem in a way that has produced consensus. The question of why trillions of micro-experiences become one experience rather than a trillion separate ones is still formally open. The split brain research complicates it further rather than resolving it, and the quantum approaches require assumptions that have not been empirically established. What you are left with is this. Panpsychism solves one problem by removing a premise. It says consciousness does not need to emerge from non-conscious matter because consciousness was never absent from matter in the first place. That is a genuine move. But it does so by generating a different problem in its place, one that is arguably just as hard. And the institutions that should be funding serious investigation into this have largely decided to leave it where it is. That gap has been sitting in the literature for decades, noted, discussed, and never closed, which should sound familiar by now. Here is the part that should stop you. Tononi and Koch have not been subtle about this. Koch has explicitly acknowledged that under IIT, very simple physical systems would have some minimal form of experience. He has called this a feature rather than a bug. The theory, in his view, does not need to limit consciousness to the systems we already know are conscious. That would be circular. A real theory of consciousness has to say something about systems we have not already classified. For over a century, physics has had a problem it cannot look at directly. Not a gap in the data, not a missing equation, a problem with what the data means, and the two answers physicists have reached are both stranger than the question they were trying to answer. That is worth stopping on, because when the most mathematically precise science ever developed produces results that nobody can coherently interpret, something is happening at the foundation that we have not yet named. Here is the experiment. Fire a single electron at a barrier with two narrow slits in it. Behind the barrier, a detection screen records where the electron lands. If the electron is a particle, it should pass through one slit or the other and hit the screen in one of two places. That is not what happens. When you fire many electrons and nobody measures which slit each one passes through, the electrons build up an interference pattern on the screen, the kind of pattern produced by waves, not particles. Ripples passing through both slits simultaneously and cancelling or reinforcing each other at different points. The electron, fired one at a time, behaves as if it went through both slits at once. Now here is where it gets uncomfortable. When you add a detector to measure which slit the electron passes through, the interference pattern disappears. Measure it and you get a particle. Leave it alone and you get a wave. The act of measurement changes the physical outcome. That is not a theoretical prediction. That is the experimental result, confirmed, replicated for over 100 years. So what does it mean? Physicists have spent a century trying to answer that without invoking consciousness, and the results are instructive. The Copenhagen interpretation, still the dominant framework used in practice, says that before measurement, a particle exists in a superposition of possible states. All possible positions, all at once, described by a wave function. Measurement collapses the wave function into a single definite outcome. Copenhagen says the wave function is a calculation tool, not a description of physical reality, which means the question of what is actually happening before measurement is not a physics question. It is simply not asked. This is not a solution. It is a decision to look elsewhere. The many worlds interpretation takes a different route. Every measurement branches the universe. Both outcomes occur. Each possibility unfolds in its own branch of reality. The wave function never collapses. It just keeps expanding into more and more branches, an infinite proliferating structure of parallel realities, each one equally real. This interpretation preserves the mathematics perfectly. It does not require any special role for the observer. What it requires is an infinite number of physical universes branching every time any quantum event occurs anywhere. Scientists who find consciousness in physics too philosophically costly have replaced it with an infinite multiverse. That trade is worth noting. Here is the thing about the measurement problem that the textbook version skips. No interpretation resolves it. Copenhagen relocates it. Many worlds expands it into infinity. Other interpretations like pilot wave theory or relational quantum mechanics each move the problem to a different address without closing it. The question of what is actually happening between one quantum state and the next observed outcome remains formally open. What does the act of measurement do, physically? Why does the outcome change depending on whether information about it is recorded? These are not philosophical add-ons to quantum mechanics. They are internal, unresolved questions in the foundations of the most successful physical theory ever constructed. Now enter consciousness. Some physicists and mathematicians in the early 20th century noticed something. The wave function collapses when an observer records a measurement. The word observer appears inside the formalism of quantum mechanics itself. John von Neumann's mathematical treatment of quantum theory placed the collapse not at the level of the detector, but at the level of the conscious observer's awareness. Eugene Wigner, a Nobel laureate in physics, took this seriously. His thought experiment, Wigner's friend, asked what happens when one observer inside a sealed laboratory performs a measurement while another observer outside does not yet know the result. By the mathematics, the system including the first observer remains in superposition until the second observer gains information. The conscious mind, in Wigner's framework, is not incidental to collapse. It is the mechanism. Most physicists rejected this, still do, but the question did not go away. It moved. Roger Penrose approached it from a different direction. Penrose is not a fringe figure. He shared the Nobel Prize in Physics in 2020 for work on black holes and general relativity. His position on consciousness is specific and frequently misrepresented. The popular version says Penrose believes quantum mechanics proves consciousness is special. That is not what he argues. Penrose argues that quantum wave function collapse is not explained by current quantum theory. He argues the collapse is a real physical process, not a calculational artifact, and that it involves quantum gravity, effects operating at a scale where general relativity and quantum mechanics intersect, a regime where no complete theory yet exists. Working with anesthesiologist Stuart Hameroff, Penrose proposed that this process, called orchestrated objective reduction, occurs inside protein structures called microtubules within neurons. The claim is that consciousness arises from genuine quantum gravitational events happening inside the brain, not from classical neural computation alone. Is this proven? No. The microtubule hypothesis remains contested. Critics argue neurons are too warm and wet for quantum coherence to survive long enough to matter. Hameroff and Penrose dispute this. The experimental evidence is incomplete. OR is a serious proposal by serious scientists working at the edge of what current physics can test. It sits, like Frankenschmidt's paper on the geological record, in a space where the logic holds and the data is insufficient to confirm or refute it, and the field has not rushed to produce that data. Here is my position on that. Two of the deepest unsolved problems in all of science keep appearing in each other's explanations, and the field has not seriously asked whether that is a coincidence. There is a version of this argument that runs in exactly the opposite direction, and it is the one that makes physicists the most uncomfortable. Everything covered so far has moved upward. Particles have micro-experience. Those experiences combine. Complexity increases. Something like awareness emerges at higher levels of organization. That is the bottom-up story, and it has a serious internal problem, which is the combination problem. How do trillions of separate micro-experiences unify into one conscious mind? Nobody has answered that cleanly. The frameworks exist, the attempts are serious, but the gap remains open. Cosmopsychism does not try to close that gap. It dissolves it by changing the direction entirely. The universe's consciousness does not build up from particles. It comes down from the whole. The cosmos, taken as a single unified system, is the primary conscious entity. What you experience as your mind is not a product assembled from unconscious components. It is a localization, a region of the total system becoming, in some sense, aware of itself through a particular arrangement of matter. The ocean is conscious. You are a wave. Here is why that framing is philosophically cleaner than it sounds. The combination problem only exists because you start with many separate units and ask how they merge into one. Cosmopsychism never starts with many, it starts with one. The universe is not a collection of things, it is a single system with internal structure. Particles, fields, forces, these are all features of one continuous physical reality, not independent objects that happen to coexist. If consciousness belongs to that system as a whole, the problem of combining separate consciousnesses never arises. There is nothing to combine, there is only the whole, expressing itself through its parts. This is not a new idea dressed in scientific language. Alfred North Whitehead was working in this direction in the early 20th century. The Stoics had something structurally similar. What is new is that the problems motivating it are now published in peer-reviewed journals and sitting formally unanswered in the literature, which changes what it means to take cosmopsychism seriously. It is no longer just a philosophical position with ancient roots. It is a candidate answer to a formally acknowledged scientific problem. Now look at what it would actually mean if the cosmic whole came first. One of the strangest facts in all of physics is that the universe appears fine-tuned. The gravitational constant, the speed of light, the mass of the electron, the cosmological constant. These values are not derived from anything deeper. They are what they are, and if any of them shifted by a fraction, atoms would not form, stars would not ignite, chemistry would be impossible, and no one would be here to notice. The standard responses to this are two. Either there are vast numbers of universes with different constants, and we happen to be in the one that works, or it is a brute coincidence, and asking why is a category error. Both of those answers require you to be comfortable with something very large left unexplained. Cosmopsychism offers a third structural option. If the universe has something like awareness woven into it from the beginning, then the fine-tuning is not a coincidence that needs explaining away, and it is not a multiverse problem requiring an infinite ensemble of unobservable realities. It is what you would expect from a system that is, in some sense, oriented toward its own organization and complexity, not designed in the religious sense, not governed by a personal agent with intentions. A structural feature of a conscious cosmos, the same way a living organism maintains conditions favorable to its own persistence without any individual cell making that decision. What this is not claiming matters as much as what it is. Cosmopsychism is not a God argument. It does not require a designer, a creator, or anything outside the universe exerting influence on it. The claim is entirely internal to physics. The universe is a system. That system has a property, something like experience, something like interiority, that is as fundamental as mass or charge. That property does not get added at some threshold of complexity. It does not emerge from matter that previously had none of it. It is there from the beginning because it belongs to the whole, and the whole has always existed as a single unified thing. Does that sound unfalsifiable? That objection deserves a direct answer. The honest position is that cosmopsychism is not testable with current instruments. We do not have a consciousness meter we can point at the vacuum and get a reading, but that is also true of large sections of string theory, of most multiverse proposals, of the many worlds interpretation of quantum mechanics. Untestable right now is not the same as untestable in principle. What cosmopsychism predicts is that consciousness should appear reliably wherever physical conditions permit it, not as a rare accident, but as the system expressing a property it already has. That is a different prediction than standard physicalism makes. At sufficient resolution, those predictions should diverge, and here is the part worth sitting with. We have now covered two separate unsolved problems: why quantum systems behave as they do under observation, and why physical processes produce subjective experience at all. Both problems resist every approach that treats consciousness as a late arrival in a universe that started without it. Both problems look more tractable, though not solved, when you allow that consciousness might be a feature of the system from the start. Two independent lines pointing at the same structural gap is not proof, but it is a signal. A universe that is fine-tuned in ways that allow observers to exist, that produces consciousness reliably wherever conditions permit, that follows laws elegant enough to be comprehensible. That is not obviously the description of a system with no interior. What happened after the hard problem of consciousness was formally named, rigorously defined, and published in one of the most cited philosophy papers of the last century. David Chalmers published that paper in 1995. It has been cited thousands of times. It is taught in philosophy departments at every major university, and the central question it raised, why does physical processing produce subjective experience at all, remains formally unanswered. 30 years, no consensus, no closing argument. The question sits exactly where Chalmers left it. Here is the thing. That is not how science normally works. When a real problem gets clearly defined and published by a credentialed researcher, the field moves on it. Other scientists test the framing. They propose solutions. They try to break the question apart and find out where it goes wrong. That process happened here too. Hundreds of papers followed. Entire journals dedicated to consciousness studies appeared. And at the end of 30 years of engagement, the hard problem is still hard. Not because nobody tried, because the structural gap the question identifies has not been closed by any amount of empirical data about neural correlates or brain imaging. The problem is not that we lack information about what the brain does. The problem is that information about what the brain does not explain why doing it produces experience. That distinction matters, and the field has been quietly avoiding it. Now look at integrated information theory. Giulio Tononi published the first version in 2004. Christof Koch, one of the most respected neuroscientists working today, called it the only really promising fundamental theory of consciousness. The theory's mathematical implications point directly toward panpsychism. Any system with non-zero phi has some degree of experience. That is not a fringe reading of the theory. That is what the mathematics says. What happened after that implication became clear? The mainstream acknowledged it, noted it as philosophically interesting, and moved on. The panpsychist implications of the most rigorous formal theory of consciousness in the published literature have been sitting in plain sight for 20 years. No serious funded research program has been built around testing them. No major institution has committed resources to following where the math leads. The quantum consciousness connection is the same story. Penrose published the orchestrated objective reduction model in the 1990s. A physicist of his standing does not publish speculatively. The model is technically dense, mathematically serious, and it links the two deepest unsolved problems in science, quantum measurement and subjective experience, through a specific physical mechanism. It has been debated, criticized, and partially defended ever since. What it has not been is resolved. The question of whether consciousness plays a constitutive role in quantum measurement is still open. It is still open because it is hard, because the instruments required to test it properly may not exist yet, and because the field has not prioritized building them. This is what warrants your genuine pause. This is not a pattern of failure. It is a pattern of avoidance. And the reason it looks like avoidance rather than just difficulty is the professional structure of academic science. Careers are built on frameworks. A researcher who spends 30 years working within the assumption that consciousness is an emergent property of complex physical systems has built everything: publications, grant applications, reputation, graduate students, on that assumption. Asking whether consciousness is instead fundamental does not just open a new research question, it threatens the load-bearing wall of a career. The asymmetry is brutal and simple. Ask the question publicly, commit to it, and turn out to be wrong, and your credibility absorbs a permanent cost. Stay quiet, continue publishing within established frameworks, and nothing happens to you personally. The question goes unanswered, but that is someone else's problem. This is not a conspiracy. There is no coordinated decision to suppress these questions. The silence is the natural output of a professional system that rewards incremental progress within accepted frameworks and penalizes challenges to foundational assumptions. Every individual in that system is making a rational career calculation. The collective result is that the most important questions stay formally open while the field moves sideways around them. What does that look like from the outside? It looks like 30 years of consciousness research that has mapped the brain in extraordinary detail and never answered the hard problem. It looks like a mathematical theory of consciousness whose panpsychist implications have been politely bracketed. It looks like a quantum consciousness framework from one of the most decorated physicists alive that has neither been conclusively falsified nor seriously tested. It looks like researchers who pursue these connections describing the same institutional friction: the career warnings, the quiet suggestions to work on something more tractable, the grant applications that don't get funded. The absence of follow-up is not neutrality. When a formally published question receives engagement at the level of citation and acknowledgement, but not at the level of funded investigation and institutional commitment, that gap is information. It tells you something about where the field is willing to look and where it has quietly decided not to. The hard problem has been in the peer-reviewed literature for 3 decades. IIT's implications have been visible for 2. The quantum consciousness connection has been a serious formal proposal since the 1990s. None of these questions have received the institutional response that their formal standing would predict. 7 years of institutional silence after a formally published question is not the field being careful. It is the field being comfortable, and the difference matters. Here is what it actually means, not poetically, physically. If the answer to the question in the title is yes, not what it means for your spiritual life, not what it means for how you feel walking outside at night, what it means for the actual structure of the universe, the timeline, the physical history of everything, because those are different questions, and the second one is the one that matters here. Start with the timeline. The universe is approximately 13.8 billion years old. The first particles existed within fractions of a second after the Big Bang. If consciousness is a fundamental property of matter, if something like experience is present wherever matter exists, the way mass is present, the way charge is present, then the history of the cosmos is not a history of dead physics that eventually, accidentally, produced minds. It is a history of experience, 13.8 billion years of it. That is not a poetic reframing. That is a direct physical implication of the claim. If panpsychism is correct, experience did not begin when the first neuron fired. It began when the first particle existed, and the distance between those two events is almost the entire age of the universe. Here is the thing that follows from that automatically. Your consciousness is not an anomaly. It is not something foreign dropped into a dead system. It is the universe doing something it has already been doing for 13.8 billion years, just at a new level of complexity. Think about what that actually means. The subjective experience of reading these words, of following an argument, of having a reaction, none of that came from nowhere. The raw material for experience was already present in the hydrogen that formed the first stars. Those stars collapsed and seeded galaxies with heavier elements. Those elements eventually assembled into neurons. The neurons integrated information at a scale that produced the kind of experience you are having right now. The complexity increased. The experience did not arrive from outside. It was already there, at every stage, in a simpler form. That is the claim, and it has a specific physical meaning. Now look at what this does to our standard picture of the mind. The standard picture is isolation. Your consciousness is a local event, produced by your particular arrangement of neurons, enclosed in your skull, invisible to everything outside it. It begins when your brain develops sufficiently and ends when your brain stops. Under that picture, minds are islands. Rare, fragile, temporary islands in a universe that has no interest in producing them. What panpsychism and cosmopsychism both challenge is not the neuroscience of how your brain works. They challenge that picture of isolation. If experience is fundamental, your mind is not an island, it is a location, a point where the universe has organized itself into something complex enough to have the kind of experience that can examine itself. That distinction matters. An island is separate from the ocean. A wave is not separate from it. This is the moment where your thinking should grind to a halt. If consciousness is fundamental and the universe has been producing it reliably wherever conditions permit, in increasingly complex arrangements over billions of years, then the Fermi paradox gets stranger, not simpler. The Fermi paradox is the question of why a universe this old and this large appears to contain so few signals from other minds. If consciousness is rare, a late accident in a mostly dead cosmos, then the silence makes a certain kind of sense. Rare things are mostly absent. But if consciousness is woven into the structure of reality, if the universe has been organizing matter toward experience for 13.8 billion years, across hundreds of billions of galaxies, then the silence is a different kind of problem. Why does a universe that is in some sense always experiencing itself produce so few points of complex experience that we cannot find each other? That question does not have a clean answer. What it has is implications. Either the universe's capacity for consciousness rarely reaches the level of complexity required for communication, or it reaches it and collapses, or we are looking for the wrong signal entirely. None of those options are comfortable. All of them are worth asking. What remains formally unanswered is not a small thing. We do not know whether IIT's phi metric actually tracks consciousness or just measures information integration. We do not know whether Penrose's quantum model connects to experience in the way he claims. We do not know whether Cosmopsychism's top-down account is more coherent than micropsychism's bottom-up account, or whether either one solves the hard problem at the level of mechanism rather than just at the level of framework. The gap between having a theory and having a tested, verified, predictive account of consciousness is the same gap that has been sitting in the literature since Chalmers formally named it 30 years ago. That gap is not closed, not approximately closed, not trending toward closure. It is open, and the institutions best positioned to close it have mostly treated it as somebody else's problem. What we have instead is a convergence of lines. Neuroscience arrives at the hard problem and cannot get past it. IIT starts from information theory and ends up implying that simple physical systems have experience. Quantum mechanics produces a measurement problem that keeps referencing the observer without explaining what an observer is. Cosmopsychism offers a structural account of why the universe produces consciousness that doesn't require it to be an accident. 4 independent lines from 4 different starting points, all pointing at the same gap, all arriving at questions the field was never designed to explore. Something is happening in that gap. We know what the gap looks like. We do not know what is in it. We are not the universe's audience. And if the science points where it seems to be pointing, we may never have been. Consider now the thought experiment that settles it. You are sitting somewhere right now, reading, listening, processing words. That act of processing is happening inside a physical system made of atoms. Those atoms follow the same laws as every other atom in the universe. Nothing special about the chemistry, nothing that marks it as different from the carbon in a rock or the iron in a star. And yet something is happening in there that is not happening in the rock. Something it is like to be you, right now, in this moment, thinking about this. That is the thing we cannot explain. Not fully. Not yet. What follows is the part that should unsettle you. If consciousness is not an accident, if it is not something that appears suddenly at a certain threshold of neural complexity and vanishes just as suddenly when that complexity collapses, then what is happening in your skull right now is not a private event. It is the universe doing something it has been doing in some form since the first particles existed. You are not a closed system generating experience in isolation. You are a place where whatever runs through the fabric of reality has become specific, localized, self-aware enough to ask where it came from. That is not a metaphor. That is the structural claim that Panpsychism and Cosmopsychism and IIT all converge on from different directions. The math, the philosophy, the quantum measurement problem, all of them keep arriving at the same uncomfortable edge. Mind is not late. Mind is not an accident dropped into a dead system somewhere in the last few 100,000 years of a 14-billion-year-old universe. If the science points where it seems to be pointing, then mind was there at the beginning. And what you are experiencing right now is the universe doing what it has always done at a new level of organization. Now think about what it means to be the kind of system that can ask this question at all. You are not just conscious, you are conscious of your own consciousness. You can turn the thing around and look at itself. That is the recursive strangeness nobody in the field has fully reckoned with. The hard problem is not just that experience exists, it is that experience can examine itself. The universe has produced something that wonders about the universe. Whatever produced that capacity is either the most improbable accident in 14 billion years of cosmic history, or it is exactly what we should expect from a system where awareness is structural, not incidental. There is no neutral position here. Either consciousness is a late arriving accident with no further implications, or it is something closer to what physics calls a fundamental property. Those two positions have completely different consequences for how we study the mind, for how we fund the research, for how seriously we take the question. And the fact that we have had the hard problem in formal literature for 30 years, IIT producing panpsychist implications for 2 decades, and quantum measurement pointing at consciousness for a century, with no major funded research program specifically designed to test whether consciousness is fundamental. That is not neutrality. That is a choice. It is just a choice nobody announced out loud. What would it mean to actually pursue the answer? It would mean treating consciousness the way we treated the atom before we had instruments to measure it directly, taking the theoretical implications seriously enough to build the experimental framework, asking what a universe with fundamental consciousness should produce that a universe without it would not, looking for that difference in the data. That is science. That is the process. It is not what is happening. Here is what is happening instead. The field is producing brilliant work on the correlates of consciousness, the what, the where, the when of neural activity, and it keeps stepping around the why. The why is the hard problem. The why is the question the title of this series asked. Does the universe dream? And the honest answer after everything, after the philosophy, the neuroscience, the quantum mechanics, the institutional patterns, the 30 years of open gaps, is that we do not know. We have not funded the effort to find out. We have not built the research programs. We have not treated the question as the most important open problem in science, which is arguably what it is. The only question left is whether the civilization currently running the experiment decides that question is worth asking before it runs out of time to ask it.